Assalamualaikum and hello everybody. Today my group is going to present about experiment viscosity and density. Here is the material and apparatus, which is the vibro viscometer, engine oil, vegetable oil, stopwatch and display unit. The first step is to pour the vegetable oil into the cup. Next, attach the cup on the table by the guide and adjust the cup to the depth where the sensor and plate is submerged. The table is lifted using the knob until the vegetable oil is on the same level with the necking on the sensor plate. Turn on the display unit and the start button is pressed to display the measurement value. Get ready with a stopwatch while waiting for the first value. Start the stopwatch when the first value appears. The reading is taken at 2 minutes, 2.5 minutes, 4 minutes, 4.5 minutes until 10.5 minutes with the same increment. Clean the sensor plate and repeat the steps with water and engine oil.
In this laboratory experiment, there are three variables, which is the time, the temperature, and also the viscosity. The data obtained is recorded in the table for every 30 seconds for each liquid, which is the engine oil, vegetable oil, and also the tap water. The viscosity and time data is used to plot the graph to determine whether the liquid is Newtonian or non-Newtonian. The graph is plotted in the Excel to produce the following graph. A Newtonian fluid is one whose viscosity is not affected by shear rate. A non-Newtonian fluid displays non-linear relationship between shear stress and also the viscosity. Thus, the line of the graph for the Newtonian fluid should be horizontal. Based on the graph plotted, all the lines are horizontal with negligible changes. Thus, the findings are all the liquid tested in this experiment are all Newtonian liquid.
Based on the result, we can see that the viscosity increased as the temperature decreased. This inverse relationship suggests that heightened temperature impart greater kinetic energy to fluid molecules, disrupting molecular interaction and consequently reducing resistance to flow. This phenomenon, rooted in established scientific principles, holds significance across various applications, from industrial process to product development, where understanding and optimizing fluid behaviors are paramount. In the real world, viscosity has many applications. For example, in the food industry, it is important to control the texture of products like sauce, also in the dressing and also beverage. In the medical field, viscosity affects the flow of blood through the circulatory system, which is an important role in medical.
Viscosity is a fundamental property of fluids that quantifies their resistance to flow. It is an essential concept in many engineering disciplines as it plays a crucial role in various applications, from design pipelines and pumps to understanding blood flow in the human body. In simple terms, viscosity is like a kind of internal friction with fluid. Imagine trying to stir honey and water. Honey has a higher viscosity, making it thicker and more resistant to flow compared to the water. This difference in viscosity affects how easily the fluids can move and how they interact with other objects. In engineering world, viscosity is essential for lubrication, which is the reduction of friction between moving surfaces. Different lubricants have different viscosities, and the choice of lubricant for particular application depends on the operating conditions, such as speed, pressure, and temperature. For example, a high viscosity oil is used in a car engine to lubricate the moving parts, while a low viscosity oil is used in a bicycle chain to reduce friction and wear. Viscosity plays a significant role in ship design. Frictional resistance. As a ship moves through water, the water molecules closest to the hull adhere to it due to viscous forces. This creates a thin layer of water called the boundary layer that moves along with the ship. The friction between the moving ship and the stationary water in boundary layer creates frictional resistance, which opposes the ship's forward motion. The viscosity of the water and the weighted surface area of the hull determine the magnitude of the frictional resistance. Other than that, the viscosity of air plays a significant role in the flight of airplanes. It is the property of a fluid that resists its flow, causing internal friction between adjacent layers. In the context of airplanes, air viscosity affects several crucial aspects, including lift generation, stability control, also engine performance. Understanding how air viscosity behaves under different conditions is crucial for designing and operating airplanes efficiently and safely. Last but not least, at lower speeds, air viscosity plays a significant role in aerodynamic drag. It creates friction between the rocket and the air, hindering its movement. Optimizing the rocket's shape and using fins can mitigate this drag. Air density and viscosity are highest at sea level, leading to the most significant drag at lower altitudes. With increasing altitude, air density and viscosity decrease, reducing drag but also affecting engine performance due to thinner air intake. In conclusion, viscosity is a fundamental property of fluids with significant implications in various engineering disciplines. Understanding and manipulating viscosity effectively is crucial for optimizing performance, reducing energy consumption, and ensuring proper function in diverse applications. In general, viscosity is an important property of fluids that has a wide range of applications. By understanding viscosity, we can better predict and control the behavior of fluids in many different situations. Thank you.